Okay, this is question 2 for HL and 5 for SL. We have a Voronoi diagram here. These are cellular phone towers, T1, T2, and T3, and they're in these, well, cells of the Voronoi diagram, but let's say these regions here. And T4 is located in the shaded region. So it's somewhere in here, T4. Tim stands inside the shaded region. Explain why Tim will receive the strongest signal from tower 4. Okay, well, if he's in the shaded region, because it's a Voronoi diagram, the closest tower to anywhere in this region is going to be T4. The closest tower to anywhere in this region is T1. Anywhere in this region is T2, and anywhere in this region is T3. Okay, so I'm going to say because T4 is the closest, it's the closest tower to anywhere in the shaded region. The shaded region. Okay. B. Write down, okay, sorry, tower T2, this tower here, has coordinates -5, 9. Let's write that in here. So this is, or sorry, -9, 5. -9, 5. That is this guy here. And the edge connecting A and B has equation y equals 3, right? So this line here is y equals 3. So this, let's just, if I continue this over here, this would be 3. Write down the coordinates of tower 4. Okay, so guys, it's a Voronoi diagram, which means the edges are the perpendicular bisectors of the sites, which in this case are the towers. So if this is T2, then T4 has to be exactly, like this is like a line of symmetry, it has to be down here. This is T4. So it's going to be at -9 because it's not moving, because this is a horizontal line, it's going to be at -9. So it's going to be -9. And if this is 3, so we're at 5, this is 5, this is 3. What did I do to get from 5 to 3? I subtracted 2. So what am I going to do from 3? I'm going to subtract 2 here, so it's 1. So does that make sense kind of intuitively? We're at -9, 5. This line is the bisector of these two. So if I have to go, if I'm at 5, down to 3, down to 1. So -9, 1 is the coordinate of T4. Then finally, tower T1 has coordinate -13, 3. Find the gradient of the edge of the Voronoi diagram between T1 and T2, right? So what they're looking for here, guys, is the gradient of this line here. Now, how do we do it? Well, we get the gradient of this line, and we know, because of what a Voronoi diagram is, these are perpendicular. So let's get that gradient first. So I'm going to say gradient of, let's say T1, T2 is y2 minus y1 over x2 minus x1. This is equal to y2, let's just go with this is y2, so 5 minus this is y1, 3 over x2, -9, minus -13. Careful, that's minus. But that's nice because it's going to give me 2. 5 minus 3 is 2. And -9 plus 13 is 4. So that's equal to, that's actually equal to a half. Therefore, the gradient of the edge gradient of edge is perpendicular to this. So this gradient is a half, that's 1 over 2. What's the perpendicular gradient? Well, we flip it and change the sign. So the gradient of edge is negative 2, because it would be negative 2 over 1, which kind of makes sense if you look at it. That has a gradient of negative 2. Okay, that is question 2 for HL and 5 for SL.